ଏହି କାର୍ଯ୍ୟକ୍ରମର ସହ ପ୍ରାୟୋଜକ ହେଲେ
Dear students and my viewers, I am Panda. I welcome all of you to this online class of MBCtv, sponsored by the Jupiter group of institutions. So, children, one thing I want to say before teaching you something, that success in life is never an outcome of opportunities or circumstances, rather is of hard work and perseverance. Hard work and perseverance. What I mean to say, many often we work, we do anything to attain success, but always people search for opportunities should be there, circumstances should be conducive for me to get successful. But these two things may not be with us always, as we are now in the COVID-19, we are all of our locked down, not able to go to our institutions, not able to do our normal work, but we are doing our work. We are doing our work and we can achieve success if we have hard work and perseverance. If you go to the life history of all the scientists, all the celebrities of the world, you will find none of them have got the opportunity, none of them had the circumstances, but they have achieved their success because of their sincerity, hard work and perseverance. So, I wish and pray God to bless you with these qualities, as all of you have appeared class 10 examination and are in quest of fulfilling your aim in life. Be hardworking, be perseverant, definitely the success will be your companion. So, this class I want to devote to the language of chemistry. As I have been telling you in my last 3 classes, I have impressed you that to learn a subject, we are beginners, we are learning the chemistry, we are not accomplished, we are not have gone deep into it. But if we understand the language in which the chemistry is written, if we understand the meaning of the words that has been written or that we are going to use, then we will be successful in understanding our subject. So, today I will be going for the 2, one is called the symbol and the other is called the valency. These are the very simple things and very useful things. And first let us become what we mean by the word symbol. So, many often people say, those who teach chemistry or learn chemistry, there you have to remember the symbols. Symbol is not a chemistry word, symbol is used everywhere. For example, if you come to mathematics, we are using, if you are adding 1 and we want to add 2, then we are using the word this plus. So, this is a symbol of addition. Or we have 10, we want to divide by 5. So, this line, when one line is written and between numbers, then that is called division. So, this is we are dividing. Or when you are writing 2 lines like this, then this becomes equal to. Or the same plus sign, when you go to medical science, the doctors, they write in their vehicles the red square, they write red plus. So, that is they call as this symbol is a red cross used for the doctors, are used for anywhere there is a hospital, anywhere there is a use for this pharmaceuticals, every this. Or if you have in NCC, so when you come to the NCC or when you go to a traffic, let me go to a traffic stand, now traffic police is there in the traffic stand and he blows a whistle. Then what is the meaning of why he is blowing a whistle? So all the people are standing, all the 4 crossroads, that whistle he blows, that is called your attention please. The whistle is whistled, it means your attention please. For example, your PT, the drill sergeant, when comes to the field to conduct you the games, or you go to a referee in a football game, he blows a whistle. Suppose somebody goes out, crosses the line, he blows the whistle and then he says that means he drags the attention, beg your attention, all of you, I am begging your attention to me, then he says one symbol. Or suppose a player is fall down on the field, then he will want to go out of the sick. So he will put a symbol like this. So there he means to say that time out. Or if you have the cricket, the umpire wants to give the tell the batsman that you are out, he just raises this finger. He is not raising, if he raise 5 fingers nobody will go, but he raises the thumb, this index finger, then the players they go out. So this is the symbol of umpire that the player is out. So children, the symbol is not is used only in chemistry, symbol is used everywhere. Symbol is used everywhere. A girl when gets married, she puts a vermilion on her forehead. So that is the index that is a married woman. The girl becomes a woman, and married woman when she puts that indicated by the vermilion on her forehead. So children, don't get confused that you are doing something great. Don't try to say that I have to remember. No, nothing you have to remember. You have to forget. The more you forget, the more you remember. So the symbol is used in chemistry. Why? Because the elements were discovered. As I have told you, the matter exists in elementary state. Most of the matter they occur in their elementary state. So these elements elements were discovered: hydrogen, oxygen, nitrogen, chlorine, bromine, iodine. Like these elements were discovered. And they have the names. So the scientists they wanted to indicate them very precisely and very scientifically. So 2 words I am using here. So the symbol is a precise scientific representation of an element. So the symbol in chemistry, in symbol we say that is a precise scientific representation of chemical elements. We are chemical elements. So we use this symbol for them. So it is scientifically used, means they prepared some rules, they have prepared some rules and a code of conduct which is followed throughout the world, everybody will follow, and precise means very small place, very definite manner we can indicate it. So what they did, so after the discovery of many elements, the scientists they wanted to express the elements in a very precise manner and in their very scientific manner, which is universally accepted. It is not a symbol of India or a symbol of Africa or a symbol of America. So, everywhere the same thing. So, now what they did, they took the first letter. So, the one first, what they first do, they did they took the first letter of the element and the took as a user symbol. For example, hydrogen was discovered, the first letter of hydrogen is H. Then the boron, the first letter is B. Then carbon, the first letter they took as carbon. The nitrogen, they took the first letter as N. Then oxygen, then O. Then fluorine, F. Then sulfur, S. Phosphorus, P. Or then they, like this, elements were discovered. When the elements were discovered, they took the first letter and symbolized. For example, uranium, they took the U, first letter. Vanadium, they took the V. Then iodine, they took the first letter as I. This is the way they took the first letter of the element and they wrote the symbol. So, many elements were covered and everybody got a relief that okay, we could write the symbol, we can indicate the symbol. But soon after some time they found after hydrogen now helium is discovered. So, helium also begins its name by H. Helium also begins its name H. So, H was already used. So, what they did, they removed the first letter. So, the second method they took was what? The first and second letter. First and second letter. They took first and second letter. For example, how? Helium is He. Neon as Ne. Argon as Ar. Krypton as Kr. Like this, they took the first letter of this, they wrote. For example, lithium, they took the Li. Beryllium, first two letters is Be. Calcium, Ca. Then barium, because again no problem, beryllium is B, here barium is Ba. They use the beryllium Ba, first two letters they took. Aluminium, Al. Gallium, Za. Germanium, Ge. Silicon, they took as Si. You see, they have taken the first two letters and they could write very easily, they could write the name. For example, lanthanum, La. Cerium, Ce. Actinum, Ac. Thorium, Th. Very easily they took the, it was very easy to write these symbols, find out the symbols. For example, selenium, they took as Se. Tellurium, they took as Te. Polonium, they took as Po. Like this, the symbols where they have taken the symbols very easily, they could write the symbols for the first and two letter. Now, then elements were discovered. because the science was developing and every moment every day discoveries were made, and after the discoveries the scientists wanted to represent them. Then for example, if you come to the word, what happened? Now chlorine was there, then chromium came. Now we cannot take CH, these first two letters are same, in chlorine CH and chromium CH. So we cannot take the first letter. So then what they did, they took the third type of symbols, they used first and third letter, first and third letter. So for chlorine first is C, third is L, so they took Cl. Chromium CH, then Cr, they took Cr for chromium. Now similarly then came the manganese, magnesium is a metal and manganese is a metal, manganese is a metal. So for first and third letter they took Mg, and first and third letter they took as Mn. Now then came the cesium was discovered, then rubidium was discovered, rubidium, this become as Rb. So first and third letter they took and they could explain the elements. First arsenic is As, they took first and third letter they could take and explain. Like this, if you go to the list of the elements, already 118 elements have been discovered, and if you write the name, first write the name and find it out that what is the symbol has been used for that. Then came after that, then again elements were they present, and they found the first and third letter also could not be possible. First and third letter could not be possible. So then they went for what? First and any letter. Then became the name first and any letter, because if you go on first, second, third, fourth like this, it became difficult. For example, platinum, it becomes for Pl, they can't, P is phosphorus, Pl cannot be used. Why cannot be used? The Pl is already used as symbol, please. Then Pa they could not use, they take the Pt. So first and here fourth letter they use. Then came the palladium, so they took Pd, they took the Pd as the first and fourth letter they are using it. So here then came curium. Curium was according to name of Madame Curie and Marie Curie, they discovered the element, and in their honor the name was given to that, and then came, they gave the name as Cm. So Curium, Cu already copper is used, Cr chromium is used, Cu copper is used, then they took the first and last letter as curium. For example, you come to radon, radon was discovered. So Ra we can't take, Ra is used as radon, Ra is used, already used for radium. Then Rn they did not take, then Rd they did not use. Why? Now Rd is a symbol for rod which is used as a unit of radioactivity. Rd is used as a unit for radioactivity, so they can't use the Rd. So then Ro they did not take, the Ro they did not take. Why? Now, because RO is a rho, the pronunciation is rho, and rho is a pronunciation is used word used to indicate density. Rho is for density. So, they went for first and last letter, then became the radon RN. Radon. So, this is the way the symbols were used, and these symbols that could not then came many elements, they could not explain those elements, they could not symbolize those elements. And so, after we are going for a small break. After the break, we will discuss the symbol for the other elements whose name could not come from the English name. So, we have seen when you take the English name of the elements, that could not the symbol could not be taken from them. For example, sodium. For example, the sodium. Sodium was a very simple element, and it became difficult to write its symbol. Sodium. S is used for sulfur. SO is used for so. SD is used for signed. SI is used for silicon. SU they could not take because S is already used in physics, U is already used as a velocity. So, SM already samarium it is used. So, for sodium they could not find the symbol. So, then what happens in English, as we have our vernaculars in India, in our Odia, then Bengali, then Telugu, then comes Tamil, Malayalam, and all these vernaculars we have, all these languages we have, their basic comes from our Sanskrit. Most of the names they came from our Sanskrit. So, the Sanskrit of English is what? The Latin. So, they went to the Latin name of sodium. So, they found Latin name of sodium is natrium. Natrium is the Latin name of sodium. So, they took first two letters to write for sodium, Na. So, what they take from Latin. So, fourth type of symbol they use from Latin language. From the Latin language they took the symbol Na. Similarly, potassium, the name for potassium was found as kalium. So, they took the first letter as kalium, K. Then copper they could not find the symbol, COPPER. CO is used for cobalt, C is used for cerium, Cr is used for chromium. So, then what they did, they went for the cuprum. Cuprum is the Latin name, so they took for the copper. Now, if you come to the silver, so they went to the Latin name, it's a silver's Latin name is argentum. So, its name is argentum. So, they took the first two letters here, Az. Similarly, question comes iron. Its Latin name is ferrum. So, they took the first two letters here is iron, its symbol is used as Fe. Gold, for gold Latin language is Arium. So, they took as Au. Like this, the symbols were taken from Latin and French language, and the symbols were found out. And so, children, here I am having the periodic table. You see here it is a periodic table. तमे एटा स्कूल रे पर्याय सरणी बोली पढ़ीथिलो. स्कूल रे हमको पढ़ाई थिला पर्याय सरणी. सरणी माने कोन? गोटे जिनिस को जदि गोटे बहुत साइंटिफिक प्रांजल भाव रे सिस्टमैटिक मैनर रे रूल्स रेगुलेशन फॉलो के लिखा जाए ताको कहा जाए सरणी. एणु एई भितरे एलिमेंट गुडा को सब लिखा जाइछि. एलिमेंट लिखा जाइछि केमती ना गोटे पर्याय रे लिखा जाइछि. किछि एलिमेंट ऊपर तळु को लिखा जाइछि आउ किछि एलिमेंट तळु लेफ्ट टू राइट को जाइछि. सो दिस इज द पीरियोडिक टेबल. This was discovered by Mendeleev in the year 1869. This was discovered. Then the development of the periodic table went on with the discovery of atomic structure. In 1913, the periodic table was rewritten by Moseley as a modern periodic table. Then now we are using the long form of periodic table. So you have the chemistry book, then go to the chemistry book, you have the symbol is written, and below the symbol a name is given. So you try to, so the top to bottom it is called as a group. Vertical lines, these vertical lines of the periodic table, they are called as groups, and horizontal lines are called as periods. They are called as periods. From left to right they are called as periods, and from the top to bottom it is called as a group. So you go to a group every day, there are 7 days in a week. So you have 7 periods. There are 7 periods, and periodic table has also 7 periods, and you have 7 days in a group, in a day, in a week. So 1 week, 2 week, 3rd week, 4th week, like this you go from left to right, write the name of the element, then write the symbol, write the name of the element, write the symbol first, then you arrange them first letter, first second letter, first third letter, first any letter, then you go to by the Latin language. If you do it today, then by the evening tonight you will can write the symbol for every element and go on doing it every day for a week. This will become a way of life. You will not remember the periodic table will remember you. So this is the way you can capture this the symbols of the element. Then after the symbols now comes the next word, the valency. 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 V-A-L-E-N-C-Y. Now why this valency came again? Many often question comes. So always there is a word, there is a saying in English, necessity is mother of invention. Necessity is mother of invention. Whenever we need something, we try to find out, face a problem, we try to find out a solution. That solution becomes a new thing for us, and we accept it and then adapt it. So what has happened? For example, elements, we know that at the atom of the elements take part in chemical combination. I taught you while teaching you Dalton's atomic theory, the atom is the smallest particle of an element, may or may not have free existence, cannot be further subdivided, and atom is responsible for all physical and chemical properties of the elements. Then we read the compound. There we have discussed that atoms of different element combine in definite ratio to form a molecule of the compound. So at that time I have underlined that word. If you see your notes which I have taught you, I have underlined that word in definite ratio. Then why definite ratio? Why definite ratio? Question comes to mind. Atoms will combine, yes, combine, they will become friends. Then why 1 for 2, 1 for 3, 1 for 4? Why this will happen? Because they are very disciplined. They are very disciplined, and so they are indexed. They are indexed. So how it came? Now for example, we take hydrogen and combine with chlorine. We got the compound as HCl, hydrogen chloride. Now we take the same chlorine, allow to combine with lithium, we got lithium chloride. But the moment we took calcium and combined with chlorine, it was found one calcium atom combined with 2 atoms of chlorine to form CaCl2. Then same chlorine, when we took the aluminium. We took the aluminium and it found 1 atom of aluminium required 3 atoms of chlorine. 3 atoms of chlorine, they satisfied 1 atom of aluminium to form aluminium chloride. aluminum chloride. Exactly when you come to carbon and it is allowed to react with chlorine, then they found one atom of carbon requires 4 atoms of chlorine and it forms CCl4 carbon tetrachloride. Now, see, chlorine is same. When we go on changing the element, the number of atoms required to combine with one atom of an element are differing. Why this happened? Why this happens? What is the reason for this? Because atoms of different element have different properties. So, to explain this at that time, they say that is called the combining capacity. One atom of combines with other element, and the combining capacity of lithium with respect to chlorine is 1, with respect to calcium is 3, and with respect to aluminum 3, when you come to calcium 2, copper 4, like this. So, to explain this, they use a word that is called the combining capacity. So, they wanted to explain the combining capacity, it becomes a big word. So, they went for the Greek language, the Sanskrit of the English. So, in Greek, Valencia means ability. Valencia, it means ability. So, ability to combine, ability to combine. So, from Valencia word they came to, in English they wrote as Valency. Some people they write Valency, or some they write also spelling of Valency CE. Some use CE, some use Y. You can write Valency, you can write at the end E, or write in the C, Y. So, to explain the combining capacity, so they use the word valency. So, this valency, if you come, then how this valency is defined? The valency is a number. The valency is a number. Very rarely book gives you this word, they use this word. So, you start your learning, the valency is a number. I am using the word, I am underlining the word number, I will explain the word number, which explains the combining capacity of atom of an element with respect to hydrogen as 1. Hydrogen as 1. That means they took the hydrogen, I have explained you already, was taken as the fundamental brick in the walls of the chemistry. Everything was defined according to hydrogen, because it is the simplest, smallest element, and later on also when atomic structure was discovered, it was confirmed the hydrogen atom contains 1 electron and 1 proton, and the simplest element, and hydrogen was taken as the standard, and its valency was taken as 1. Taking the hydrogen as the combining capacity 1, the combining capacity of all these elements, we have the periodic table, all these elements were scaled down, all the elements were, their combining capacity were scaled down. So, the scale unit is taken a hydrogen, we have 12 inches in a scale. If you see 1, 2, 3, 4 up to 12 is written, means every part is an inch, every part is an inch, you have 12 divisions, every part is an inch. So, here also that means a unit is the inch is the unit. If you to go to a centimeter scale, you go for 1 centimeter as the unit. Here also the hydrogen is taken, the combining capacity of hydrogen is taken as the unit as 1, and taking the hydrogen capacity as 1, the element capacity of all other elements, they were scaled down, or that is called the valency. Is the valency is a number which explains the combining capacity of the atom of an element. So, then what are the characteristics of this valency? We will go to know the valency of the elements. So, what is this? Is a combining capacity, is a combining capacity and number. If you took these two, children, many mistakes, generally very many people that do, you will not commit, because I have been telling you from my first class, you try to learn. If you learn, you will understand. If you understand, you earn the knowledge, and after the knowledge, you become a wisdom, you gain the wisdom of it, and once you culture the wisdom, then nothing will be a problem for you. So, when you question number 1, 2, 3, 4, 6, 7, 8, 9, they are what? Numbers. We are not writing plus or minus before them. So, valency, when you say is a number, so valency will not have any sign. Valency will not have any. Many often people say valency of chlorine -1, valency of oxygen -2. They tell like this. That is a totally wrong thing they are telling it. Many often people say in the school also, when you have read valency of oxygen -2, valency of calcium +2, valency of barium +2, like this we write. Yes, we wrote at that time because we cannot understand at that time. Now we are going to understand each one, because these words we will not learn again in our lifetime. Whatever thing we will learn now, that will be our learning for throughout our life. Hence, whatever you learn now, you will learn for all time to come. Don't skip over. This language of chemistry, it may take some time, but try to understand each word, and if you do that, I assure you, my children, then success is yours. So, then what is this? So, since valence number, so it will not have a sign, means no positive, no negative. The number, it cannot be a fraction, it cannot be a fraction. Now, question comes somebody, why not, sir, fraction? Fractional numbers we have. Now, the moment you say valency fraction, John Dalton ghost will stand in front of you. They will stand in front of you, will ask, Bhaiya, wrong thing don't do. In the 1803 I have told you what is atom, and you are writing the atom of an element. The valency, the combining capacity of atom of an element. If you write a fraction, then you are dividing the atom. If you divide the atom, I will just kill you. You are going the ghost of Dalton will stand in front of you and tell you that don't do this mistake, atom cannot be subdivided. Atom cannot be subdivided. So, the valency cannot be a fraction. Then question comes, can it be 0? It was thought to be 0 at one time, but now that 0 is not, we are not taking as 0, but it can be, it always has a number. So, number, so here the moment you say number, if you understand the meaning of the word number, you will not do this mistake. You will never write positive, you will never write negative, you will never write fraction. Then combining capacity, my eating capacity, somebody asks you, sir, what you want to take in the dinner? Now, I will take chapati. Sir, your eating capacity is 5 chapati. Okay, 6 chapati you will prepare, I will take 5 or 6 if I require. So, my eating capacity cannot be negative, because I will eat. If my eating capacity is negative, I have to take out 5 chapatis from my stomach, the negative. When it goes, you have exothermic, the heat goes exothermic, the heat comes endothermic. When heat comes endothermic, we write positive. When heat goes out, we write negative. So, combining capacity cannot be negative. So, valency cannot be negative. So, if you children, you see, this definition tells you what are the characteristics of valency. What are the characteristics of valency? So, when you come to characteristics of valency, first characteristics of valency is valency is a number. Valency is a number, so does not bear any sign. means it can be positive or negative, it is 1 or 2 or 3 or combining capacity 1, combining capacity 2 with respect to hydrogen, combining capacity like this. Then second, it cannot be a fraction. The valency cannot be a fraction. See, valency cannot be a fraction and the valency does not bear any sign, and explain the combining with respect to hydrogen as 1. So, many often we said that then how to know that this was the valency in there at that time 18, 15, 17 the science was developing and the valencies were written. Now, the science is already developed, we have come to know, then question came, then how to know the valency of the element. At the present state, it is very easy to find out the valency of the element very systematically and scientifically. We can find out the valency of an element. Valency, for example, calcium, for example, you have take carbon combines with the hydrogen. So, 4 atoms of carbon combine with the hydrogen to form methane. So, valency of carbon is 4. Silicon combines with 4 atoms of hydrogen to form silane, SiH4. 2 atoms of hydrogen combine with 1 atom of oxygen, H2O. So, valency of oxygen is 2. 1 atom of nitrogen combines 3 atoms of hydrogen. So, valency of nitrogen is 3. Valency of nitrogen is 3, valency of oxygen is 2, valency of silicon is 4, valency of carbon is 4. 1 atom of phosphorus combine with 3 atoms of hydrogen to form phosphine. So, valency of phosphorus is 3. So, like this we can then why it happens, why different elements have different valencies, why different elements they have different valencies, then how to know this, how to find it out, very scientifically how to find out. Now, the science has developed, it is the combining capacity of what, atom of an element. Now, question came, very difficult question, critical, carbon, then science developed, the organic chemistry came in, it was found carbon combined with 4 atoms of hydrogen to form CH4, because valency of carbon is 4, this is called methane, this gas is called methane. Now, carbon combines with 2 atoms of carbon combined with 4 atoms of hydrogen to form C2H4, ethylene. So, here the valency of carbon became how much, 2 atoms combined with 4. Now, 2 atoms of combined were found to form 2 atoms of hydrogen to form C2H2, acetylene. Here became big question. Now, the question came, here the valency of carbon is 4, here the valency of carbon is 2, here the valency of carbon, then this 2 atoms of carbon combined with 6 atoms of hydrogen to form C2H6, ethane. These are the compounds formed, where here the carbon has, with respect to hydrogen, the valency of carbon is 3, with respect to hydrogen the valency of carbon is 1, with respect to hydrogen the valency of carbon is 2, with respect to hydrogen the valency of carbon is 4, but carbon has valency 4 or carbon has valency 2, because a carbon combines with oxygen to form CO, carbon monoxide, carbon combines oxygen to form carbon dioxide. So, it can have valency 1, 2 or it can have valency 4, it can have valency 4. So, then 1, 2 and 4, that means carbon you are taking, we are adding oxygen, it first forms carbon monoxide. You have seen when you take a wood and burn it, you get the smoke, the धुआंटा आसुची, से धुआंटा आमर आखि को पड़िबो, तापर आमे सेथिरे गोटे बिंछना नै कि गोटे स्विंग करूछु, गोटे कागज हो कि बिंछना हो आमे नै कि ता आगरे स्विंग करिवो, देखिवो तापर से जो स्मोकटा चली जीवो, काठटा पूरा जली जीवो, सेतबेले आ धुआं हबनी, सेतबेले गरम बाहरिबो, हीट बाहरिबो आउ धुआं हेनी से कार्बन डाइऑक्साइड बाहर बोली आम कहलु कार्बन डाइऑक्साइड इज ए कलरलेस ऑर्डरलेस गैस बोली आम कहलु ताहले कौन बेसी ऑक्सीजन गला सो क्वांटिटी ऑफ ऑक्सीजन बेसी हैला सो यू गॉट कार्बन डाइऑक्साइड सो कार्बन डाइऑक्साइड कार्बन मोनोऑक्साइड प्रथम हबा तापर कार्बन मोनोऑक्साइड हैला तापर कार्बन डाइऑक्साइड हैला सो कार्बन रो दीटा वैलेंसी रहिला गोटे हला कार्बन मोनोऑक्साइड आ कार्बन रो कार्बन डाइऑक्साइड कार्बन वैलेंसी 4 टा होची मोस्ट स्टेबल एंड 2 टा होची लेस स्टेबल सो सेथि पई कार्बन रो वैलेंसी 2 निया गला किंतु एटा गोटे क्वेश्चन मार्क हे गला this became a question mark so then question came to the mind of the scientist then how to explain the valency आम एमती कौन मन रखा सब एलिमेंट प्रत्येक एलिमेंट कौन कौन वैलेंसी अच्छी आम कौन मन रखा ना सब कंपाउंड को मन रखा ना किमती कौन बाहर करवा देन दे वेंट देन व्हाट हैपेंड द साइंस डेवलप्ड द आटम which is taken as the smallest particle of an element may or may not has free existence but cannot be further subdivided was accepted but then they wanted to know why all chemical reactivity comes from carbon comes from the atom why atom reacts why atom is determining everything they wanted to know so then they wanted to know what is there inside the atom what is there inside the atom and that is called led to the structure of atom structure of atom was studied we will read separate class structure of atom now we will say that this atom consists of 3 fundamental particles that is electron it contains a negatively charged particle it contains proton and it contains neutron so this electron and proton they are called the fundamental particles they were discovered towards 1886 to 1900 तांकर discovery टा complete हे गला 86 to 1900 but the neutron was discovered in the year 1932 एनु तीनटा जगह पार्टिकल आटम भितर अच्छी the youngest particle of atom is the neutron 32 years so what is the age gap between proton and electron and neutron 32 years let neutron ta pore asichi so then the structure of atom was first studied by Rutherford he studied the structure of atom that is called Rutherford model of atom then atom he you have read in class 10 you have read already that atom consists of 3 fundamental particles the proton and neutron they are placed at the center that is called as the nucleus this contains proton and neutron and these electrons are the negatively charged particles they are moving around the nucleus they are moving around the nucleus Rutherford told it is they are moving in circular orbit then came the Bohr in 1913 he said the electron this nucleus is there at one of the focus the electron is moving in an elliptical orbit just like our earth and sun the earth is moving around the sun in an elliptical orbit अंडाकृति बोली जो आमे कहूँ कक्षरे बुले बोली कहूँ so the particle is moving and also moving while moving it is moving like this it is moving like this it moves around its own axis and also moves around the axis of the earth so exactly same thing the electron also moves like this and also moves around the nucleus so the proton and neutron they are inside the nucleus they will not take part in chemical combination who takes part in chemical combination now who electron will take part in the chemical combination so this was the idea came to the mind of the scientist this idea came to the mind of the scientist so then what you are reading now combining capacity we are going to the combining capacity so suppose somebody asked me sir you are eating why you are eating now I am eating not to eat I am eating not to eat what do you mean by that I am not eating not to eat now because I after eating I will not eat after complete my eating I will not eat similarly when atom combines the atom combines what to not to combine again not to combine again it becomes stable it loses its combining capacity, is neutralized. So, that means it becomes inactive, element becomes inactive, the atom becomes inactive. So, this way the science was developing. In the earth, slowly then different elements were discovered, the rare gases were discovered. The rare gases were discovered. These rare gases were helium, argon, krypton, xenon and krypton, helium, argon, krypton, xenon, radon, like this the elements were, these rare gas elements were discovered. So, helium was found to have a 2 atomic number and it has found to have 2, I wrote here neon, then comes argon. So, argon, neon has atomic number 10 and it has a 2 8, 10 electrons. So, 2 and 8. Argon was found to have 2 8 8. Krypton was found to have 54, here it is 54, that is 2, then krypton was 2 8 18 8, then came xenon 2 8 18 18 8, and then came the radon 2 8 18 32 18 8. So, you find all these elements, they have 8 electrons in their outermost shell and they do not take part in chemical combination. So, taking this, the valency of definition then developed, that is called electronic theory of valency, and we will discuss in our next class how the valency came or developed, modern definition of valency, that is called electronic theory of valency. We will explain this valency from the periodic table. Next class, if I will come, I will explain you this valency. Thank you children very much. If you have any doubt, you can ask us the questions, you can write the questions and send us, so that next class when I will come, I will explain your doubts. So, go through this and try to understand everything that you have done. Thank you very much.
ଏହି କାର୍ଯ୍ୟକ୍ରମର ସହ ପ୍ରାୟୋଜକ ହେଲେ